Hey guys, this lesson we're going to look at retirement accounts and some annuities and things like that. Much more fun because it's not debt, it's actually making money. I think it's a much more fun way to look at money. Not when it costs you, but when it makes you money. Alright, an annuity is an account. You have scheduled payments, a sequence of scheduled payments is made. Two types of annuities that we're going to look at are ordinary fixed annuities and a sinking fund. An ordinary or fixed annuity, you have scheduled payments are made at regular intervals with interest compounded at the end of the intervals with a fixed interest rate. The payment period and frequency of compounding are the same. And you can determine the accumulated amount over a number of years. So like you'd be putting money into it to save for later. So here's the formula for it. It looks a little bit complicated, but it's actually that 1 plus r over n to the nt formula that we've used before, but then minus 1, and then over divided by r over n. So A is the final amount, P is the payment amount. Number of times interest is compounded is n, same as last time we used this similar formula. T is in years, R is the rate, but you plug it in as a decimal, same as other times we've used all of these letters. So again, we wrote it before that it spells out the word parent, just without the E, and that's still the case here. P-A-R, no E, N-T, parent. So we're going to look at builds depositing $250 each quarter into an ordinary annuity that pays 4% interest compounded quarterly. So it pays in each quarter and it's compounded each quarter. We mentioned that those need to match for this formula. Determine the accumulated amount in this annuity after 35 years. So looking back at our formula, A is the final accumulated amount, P is the payment amount. So the payment amount is $250. So the payment amount is $250. We're asking for the final amount, which is A, number of times compounded per year. It said that was quarterly, so 4 times. T is how many years. R is the rate as a decimal. So T is 35 years, and then R is the rate as a decimal, which would be 0.04 for 4%. And we're going to solve for A. So that formula was P 1 plus R over N to the NT minus 1 over R over N. So we've got 251 plus 0.04 divided by 4 will be 0.01 to the NT 4 times 35 over R over N. And then R over N, we did that a little bit ago, that was 0.01. So 1 plus 0.01 is 1.01 to the power of 140 minus 1 times 250, and then divided by 0.01. So according to this formula, it would be 75,677 and 48 cents. All right, similar sort of problem here. We have another ordinary annuity. They invest $500 each month in an ordinary annuity with 6% interest. So let's go ahead and fill out determine the accumulated amount. So that's A. The payments are $500. The interest rate is 6%, so 0.06. Compounded monthly means 12. And remember, they compound monthly and deposit monthly. That's supposed to match for the formula. And then after 18 years, because they were doing it for college, so they started when they were born, went till they were 18. So our formula starts with a P, and then it's 1 plus R over N, 0.06 divided by 12. 6 over 12 is a half, so this is going to be 0.5 with a couple extra zeros there. We are going to be adding 1 onto that, so if you just want to take care of that right now, not worry about scientific notation, you can do that. But this was 0.005. The exponent is n times t, which is 12 times 18. So the exponent is 216. And then you subtract the 1, and you divide by r over n, which is the same decimal here, 0.005. So 1.005 to the 216th minus 1, and then times 500. And then we divide by 0.005. 193 676, and then that would be 60 cents. All right, now we're going to look at sinking funds. It's a different type of annuity. The goal is to save a specific amount of money in a specific amount of time. So if you knew how much you wanted by a certain date, it'll help you figure out how to reach that goal. Round answers up to the nearest cent to reach the desired amount. So just round it up. You don't, otherwise you'll come a little bit short. So here's the formula, P, A, R, N, all that stuff, T, they all mean the same thing. So you can start by identifying those letters, P, A, R, N, T. It's a similar formula, but just flipped around a little bit, really. It's actually the exact same formula, just solved out for P instead of solved out for A. If you did the algebra and switched A and P around, you'd get the same formula as before. So he would like to have $30,000 in 5 years to buy a new piano. I decided to invest monthly in a sinking fund that pays 4.5% interest, compounded monthly. So he's investing monthly, and it's compounded monthly. Those need to match. How much should he invest each month to accumulate $30,000 in 5 years? So I like to start with the variables. The T is 5 years. N is compounded monthly, so that's 12. R is 0.045. A is 30,000. And we just plug it into that formula. A times R over N. Over 1 plus R over N to the NT. NT 5 times 12 is 60. Minus 1. So for our numerator, 30,000 times 0.045 divided by 12 is 112.5. Our denominator, plus 1 to the power of 60, and then subtract the 1, so that's 0.251795, so you can say 1/8. We'll just round that out. That's subtracting the 1. There we go. But our final answer here is going to be 112.5 divided by that number we just have written right there. So we'll just say divided by shift answer. $446.79. We do need to round that up, otherwise it'll be a little bit short. So we'll say $446.80. Otherwise you'd be a couple dollars short at the end. So real quick, let me go back to that. So even though it was like, that would have definitely rounded to 79 cents, that 0.05, you have to round up no matter what that is. Even if that was 79,000,001, you'll still have to round that up. Just 1 penny more, always. Becky wants to be a millionaire in 20 years. Good idea. How much would she need to invest quarterly into a sinking fund paying 8% interest? So she wants 1 million. The rate is 8%. Compounded quarterly, that's 4 times. And it said 20 years. So it's A times R over N divided by 1 plus R over N to the NT. 4 times 20 is 80. And then minus 1. So that 0.08 divided by 4. 8 divided by 4 would be 2, so it's going to be 0.02. Just got to keep the decimals in there. And times a million. It's 20,000. And then for our denominator, that would be 1.02. Then to the power of 80, subtract 1 from that, it's 3.875. So we'll actually subtract 1 so we don't need to retype, and then we'll do the 20,000 divided by answer. So 70 cents, then the 5, you're going to have to round that up to 71 cents. So 51, 60, 71. Takes a lot to become a millionaire in 20 years. Doesn't take that much, however, to become a millionaire in like 40 years. Now this is quarterly also, so divide that by 4, it's like 1,000 something, 1,300 a month approximately. Not too bad, but if you're giving yourself more time, if you give yourself like 40 or actually 50 years investing, you can become a millionaire for like, I think it's like $100, $100 a month or something like that. But you have to do it for a long period of time. All right, so some other annuities out there are variable. Interest rates vary and depend on the stock market. That's pretty common. That's how a lot of investments go. There's no guarantees, lots of possible risk, and a lot of gain. And the money can be tax deferred. Sometimes it's actually tax free, depending on how you do it. If you pay taxes first or not. So, but that's typically that's how mine personally is. It's stock market dependent, and for the most part, that's just perfectly fine over a long period of time. An immediate annuity, a lump sum is invested up front and paid out in regular intervals. And an IRA, individual retirement account, these are my favorite. Specifically a Roth IRA, we'll talk about that though. But you invest pre-tax money, so it gets taken out of your paycheck or whatever before, taken out of your paycheck before you ever see it, before it gets taxed, all of that. It grows. This one's got a fixed interest rate, and you do have limits set in place and things like that. I believe a Roth IRA, the difference is it's actually post-tax money, and you pay taxes before, and then you don't have to pay taxes later, actually. The most common that people hear about is a 401k. Sometimes there's different letters and numbers based off of the type of company you work for. 401k is most businesses, teachers, and people that work in a church and things like that are actually eligible for a 403b. It's the same thing. And again, it can be taken out before taxes. Usually, if they add in that word Roth, it means it's after taxes. Sometimes employers will match, which is really, really nice, up to a certain percentage. That's what my wife is able to do. I think it's a 5% match that she gets right now. So they take 5% of her paycheck, and then the company matches that 5%. So it's like 10% of her money is invested, but it only costs us half that. And legally, you're allowed to take loans against a 401k. Personally, not a fan of that idea, but sometimes maybe you have to. Here we go. There's a 403b. Basically, it's the same idea, just like a 401k, different letters for different type of company that you work for. Can be matches on these too. that is it. You've got a worksheet in the Files tab. Post your questions and comments, and see you next time. Bye.